Inheritance is a way for us to derive one class from another class. You have a parent class and then a child class. When you derive the child class, it will inherit the properties, the methods, and the events of the base class. You can override methods if you want to. So if there's a method that is in there and it works in a way that you don't like, you can override that method and give your own code having it do what you wanted it to do. In Visual Studio 6.0, VB only supported interface inheritance. It was actually still pretty clever to use it. I used it on a number of projects, and what it allowed you to do is basically set up a class that had nothing but interfaces and no code. You could then implement that class and add code that did what you wanted your application to do. The difference is that now in Visual Studio.net, we can inherit not only the interfaces, but the full implementation of the class. So all of the languages in Visual Studio.net are fully object-oriented. Let's take a look at an example of inheritance and how this might work. So what we see here is a member object. So this member has a name and an ID number. The two classes that we see at the bottom, primary member and secondary member, are the derived classes. The primary member class and secondary member classes, they will both have this ID value as well as a name. So these are two properties that will also be part of these other two classes. There is also an add and a delete method. The primary and secondary members will also have add and delete. They will also have the visit method. However, primary and secondary member will have their own custom properties and methods. So we can add to what the member class gave us. So for example, primary member has a secondary members property which will return a collection of all of our secondary members. Secondary member has a sponsoring member property which will return the full object of the primary member. So what we can see in here is that we have one base class, our member, that is used to derive two new classes, primary and secondary, each of which will inherit the properties and methods of this member class, as well as add their own new ones. The benefits of inheritance are that our derived classes will inherit the data, the properties, methods, the events of these base classes, which means we can reuse code. We don't have to rewrite it every time. The base class can also be extended. So if the base class doesn't have a method that we want, we can just add one in. This is really nice because what we can do then is have global behaviors, global properties, as well as some private internal settings inside the base class that will then be shared throughout all of the classes that inherit it. In an enterprise environment, this is essential, where there are a lot of demands placed on the IT staff to create software for different divisions or different areas, sectors within the company. Some of that activity is going to be the same over and over and over. And it's even true in a work group environment. To make it easier on us, what we can do then is just use inheritance to allow our code to be more reusable. Something that is related to inheritance but is not exactly the same is polymorphism. Polymorphism allows us to take a base class, derive another class, but then have the methods from that base class actually do something completely different. So the same methods in our base class can be called to perform different actions depending on some things we do within the runtime. The client doesn't have to worry about how this derived class was instanced or even that it's being extended in this unique way. Often, polymorphism is done through interface inheritance. So in our previous example of object orientation, the member object, or the member class in that case, the member class had a visit method. What if our secondary member, once we derive that, we wanted it to execute the visit method, but do something very different than either a member or a primary member does? Here's how that would work. We have class number 1. Class 1 is the one that just defines our interfaces. This would be like member. It would have interfaces, but let's just say for now that it has no code. So it has a visit method, but it has no code behind it. What we can do then is we create our client class. So at the bottom we see client class, and what client class is going to do for us is it's going to be an instance of class 1. Client class will then have this visit method. However, we have two other classes, classes A and B. These two classes are derived classes from class 1. They have the same visit method. However, in class A, visit is done one way, and in class B, it's done a different way. What we will do then is, as we instance this client class, we can change whether we're using class A or class B behind the scenes to run this visit method. So if our class 1 is really a class A, when we execute the visit method, client class is going to do whatever the implementation is within class A. If our class 1 is really a class B behind the scenes, when our client class executes the visit method, it will execute whatever the code is behind class B. So it's functionality specific to our class implementation. The last aspect of object orientation we're going to look at is encapsulation. Encapsulation is actually pretty easy to understand. A lot of times it's referred to as the black box. What's going on inside of this black box, we don't know. All we know is that it does certain things. It exposes some interfaces to us. We can interact with it. We understand its behaviors, its properties, its methods, its events. We know its attributes, but we don't know how internally it's actually doing those. So encapsulation amounts to abstracting or hiding the details of these inner workings from the object that we're instantiating. The benefits are that we can have a class with a full implementation behind it, and the developers who instantiate that class don't have to worry about what's going on inside of there. All they know is there is a visit method or a go get data from DB method. They don't have to worry about how it's actually working. This is pretty nice because developers can then focus on their functionality and what the application is trying to do rather than some of these implementation details. The other nice part is that if we wanted to change how, for example, database access works within this class, we can change that, and the client application that uses it will not have to worry about a change being made. So if we had a get data method inside of the class, we can change which database it's pointing to. The client application will still call the get data method like it always has, not worrying about the fact that the database has changed. This is also useful from the standpoint of security because we can embed security information within the data of a class and don't have to expose that to everyone who instantiates the class. Visual Basic takes advantage of these object-oriented features, as we've mentioned, as do all of the languages within Visual Studio. But there are some other new language features that come with VB.NET, like structured error handling, delegates, full-type safety, free threading support, also using the deployment and distribution tools and features. These are things that come with VB.NET now. Let's take a closer look at structured error handling because it's something that VB developers have been asking for a long time. Structured error handling amounts to now being able to more gracefully capture errors as they occur, do some kind of handling of the error. Maybe we want to make a correction. If a person hadn't put a valid value within a text box, we might try to correct that for them and then try it again. Or we may just throw an error and report it up to another application. We could log something within the Windows 2000 event log. There are a lot of things that we can do. But the nice part is we don't have to have a bunch of go-to statements inside of our code. Here's an example of structured error handling in VB. So what we have is try, catch, finally, and end try. These are the keywords that we're going to use. In try, this is where we'll put the code that we want to execute. So maybe there's some validation or something. That's pretty common, so we might put that here. We're going to try this code, see what happens. If there's a problem, this is where we use catch. So catch is where we look for certain exceptions. We could reference those by number, or there might be some conditions that we're trying to capture. And there's a finally, which is what we can do, if everything succeeds or if everything fails. We don't know how things have worked out, but whatever happens, this is where the code we might want to execute as we finish our error handling. C# has the same object orientation features that VB.NET has. It's a new language introduced with .NET, designed for building our enterprise applications. It has the structured error handling, has basically all of the features that we've seen inside of VB. It combines the power and the syntax of C with the rapid application capabilities of Visual Basic. This is one of the great things. Visual Basic started out as really a prototyping tool, and eventually people started creating pretty complex applications using Visual Basic. But they could do it a lot faster than a C++ developer could. C# allows us to leverage our skills in C, but still be able to create applications very quickly like we can in VB. It also supports an unsafe mode, probably won't be used very much, but this is where you can write code that's not managed by the Common Language Implementation or the CLR. So C# has some features in it that VB doesn't have, but for the most part, they are essentially synonymous languages as far as what they can accomplish. C++ developers aren't left out in the cold. All of the different capabilities within .NET that we've seen for C# and VB are also available for C++ developers using what are called the managed extensions. The managed extensions allow us to have easier interoperation between managed and unmanaged code, and that's something that we really can't do with the other two languages as well as we can here with C++. It fully supports the .NET framework, as I've said, but it doesn't have the RAD support that we've seen, for example, in VB and in C#. And the managed classes follow special managed rules. So there are some limitations in one sense of what we can do with C++ and the managed extensions. On the other hand, C++ will continue to remain really the most sophisticated programming language within the Visual Studio family.